best thing to get started. Come to information sessions like this, and I'll try to show you the website some of the things that you should look for that might help you in general for all the areas, but then specifically for the analytical reasoning part of the test. Have you been on the ETS website? Have you seen that? If you go to ets.org, you can see different tests and topics in the center. I'm going to click on the GRE test part of this, and you can go in different parts of this as far as preparing for the test and some of those types of things. I'm not going to go into that here because I have something else that you can get to that I think is at least as good and I think it's better. But if you go into prepare for the test, there's all this information here that we can use to get information about the analytical reasoning test, prepare for it, and so on. But what I really want to click on here is PowerPrep 2 software. I'm not going to click on it here, but you can get into the PowerPrep software and download that for free onto your computer. And that, I think, is one of the best ways of preparing for this test. From what I've seen that in the book and those types of things. Have you seen the PowerPrep 2 software? Has anybody gotten in it and seen that? Okay, good. Well, I've already downloaded this onto my machine. Here I'm into the PowerPrep software, and it looks much like the website does. It's going to have the same type of preparation hints, same type of practice problems or sample problems, explanations, and so on. But what this has that I don't think the website has is the opportunity to take 2 tests, practice tests, online. And I believe the first one you can take it timed or untimed, and then the second one is timed. And I encourage you to at some time do that because you're going to put yourself in a testing situation. No help, time limit, all the types of stresses that you have in testing, except it's not for real. But at least you can come through with some type of I think, a good practice session. Before I get into that, though, before I show you that, well, actually I can show you that now. Start practicing now. I believe that gets you into the tests themselves. If not, there is a way of getting into this. But what I want to show you mainly tonight, I wanted to mention that part, but I want to get into the quantitative reasoning part of PowerPrep and show you the different types of questions that are asked, the help that it gives you, or the hints that the system gives you on what to look for in that particular type of each particular type of question, and then just look at a couple of practice questions. I'm not going to go through too many, you can go through more of those, but go through a few of them. On the left-hand side, you can see the different types of questions that you're asked in this part of the test. Quantitative comparison, multiple choice, where you have one answer, multiple choice, selecting one or more answers, numeric entry, data interpretation sets, using the calculator, which isn't a test, but it's talking how to use their calculator, telling you how to use that. And then some math review, which is more general information for you. And then mathematical conventions, which again is not a test, but it talks about the different things that you should be aware of in mathematics as far as symbolism, different rules that we follow in mathematics. Probably a good thing to look over before you practice your practice test, is to remind yourself of things that you would have learned back probably in algebra, some geometry, some of the different areas. So on this left-hand side has introduction and then quantitative comparison. That's where I'm going now. This is typical for the entire, for every one of these math sections. This is typical of what you're going to see as far as the description, tips for answering, and so on. And I don't know for sure, I haven't looked at the other areas, but I imagine it's going to be the same thing for the writing and the other testing areas. On this, quantitative comparison questions. These questions compare two quantities, quantity A and quantity B, and you determine which of the following statements describes the comparison. And then notice under description we have 4 different answers that you're going to have for these questions. Quantity A is greater, quantity B is greater. The 2 quantities are equal. Or we can't determine which one is greater. And that's what you're being asked in those types of questions. Underneath that description, we have the tips for answering. Become familiar with the choices. Make sure you know what the choices all mean. Avoid unnecessary computations. Do some things mathematically maybe number sense wise. Do some things that you don't have to do all these calculations if you can avoid the calculations. We'll see a little bit of that in the practice problems. Remember that geometric figures are not necessarily drawn to scale, so segment lengths don't necessarily relate to each other in the proper scale. They're just drawn for the look of the problem, but not really drawn to scale to where you can measure things. Plug in numbers. You can put numbers in the variables and see how they compare. But if you do that, you want to make sure you put in a variety of numbers, not just positive numbers. Do some negatives, put in 0, do some different things to determine which the values A or B might be larger. And then simplify the comparison where you might have to do, or you might want to do, some algebraic manipulation. At the end of those tips, and like I said, I just went through them quickly, but you can read through them more carefully. At the end of the tips, at the very bottom of the screen, we have sample questions. And I encourage you to make sure you look at those sample questions to be prepared for your practice test, to prepare you for the actual test. Here are some sample questions. And again, they go through the directions that you're trying to select which quantity is greater, if you can tell which one is greater or if they're equal. Here is a sample problem. Number 1. Quantity A, the least prime number greater than 24. Quantity B is the greatest prime number less than 28. We want to determine which one of those is greater, or if we can even tell which one is greater. Well, again, when you look at the terminology of prime numbers, if you go through and review some of the conventions later on, or that are listed later on that page, remind yourself of some of the terminology that's involved would be helpful. It gives the explanation. For the integers greater than 24, well, the first prime number is 29. 25, 6, 7, 8 are not prime, but 29 is prime, as are 31 and other ones, but 29 would be the least one. And then of the prime numbers less than 28, 23 is the greatest one of those. And we can see that 29 is greater than 23, which means that quantity A is greater. Our choice is choice A in our list of responses. And so even once we got to the point of 29 being the smallest prime, we didn't have to really look at the primes less than 28 because 29 is bigger than all those. So again, using some reasoning can maybe help speed things up a little bit. Looking at another question, Lionel is younger than Maria. Quantity A, well, we know that Lionel is younger than Maria, but quantity A is twice Lionel's age, and quantity B is Maria's age. And we need to determine which one's greater in this case. If you look at the explanation, if Lionel's age is 6 years and Maria's age is 10 years, then quantity A is greater because twice his age would be 12. But if Lionel's age is only 4 years and Maria's is 10 years, then quantity B is greater. Therefore, we can't tell which one is greater in that situation. In that case, what they did to solve was they tried a few numbers just to see what's happening. Now, the danger in that is you might not be trying the right numbers and you might not really see the right answer. But if you don't have a better way of solving it, at least that's a way of getting some type of attempt, and hopefully it'll lead you to the right answer. And this one, just looking at this one for geometry. The main thing I want to mention about this one, we're checking to see which one is bigger between PS and SR. And what I really want to stress about this one is that we don't have this necessarily drawn to scale, but what we do know is that S is between P and R on that segment. Somewhere in between. That much we know, but we don't know how the segments really are related. If you look at the answer for this, in the solution they say that S could be anywhere along there according to the directions. Therefore, we still can't tell which one is larger of these two segments, just from the information given. So again, in that case, I just want to show that one because of the geometry aspect. You see we have in this section, we have nine sample questions. Like I said, I'm not going to go through all of them, but give you a sample of those 9. That was under quantitative comparison. Let me go down to multiple choice, select one. And again, you'll see the same view on this page as you did on the other page. As far as some type of a description, they're multiple choice where you only have one answer. And then the tips for answering, use the fact that the answer is there. If you don't see the answer there, you're doing something wrong. So the answer is given somewhere in the possible responses. examine the answer choices. Sometimes the answer, you'll see the answer fairly quickly and fairly easily. Other times you're not, so you have to do some type of work. But you might be able to determine what the answer is from substituting in or doing something like that from the problem. For questions that require approximations, scan the answer choices and see how close an approximation is needed. These answers might be so scattered out that once you get something fairly close, you're already there. You're close enough to be there that you don't have to do much more work. At the bottom again, we have sample questions. And on the first one, it gives us an equation, 5x plus 32 equals 4 minus 2x. What's the value of x? We have algebra that we can solve that with if you've been familiar enough with algebra, but let's say the equation's harder and you can't do that. You can always plug your values in one at a time, except that can be time consuming. Plug each one in, negative 4 in for x and seeing if it's equal, negative 3 and so on. In this case, they solved it. Added 2x to both sides and subtracted 32 to get 7x equals negative 28. Dividing by 7, we get x equals negative 4. Algebra is probably the fastest way of doing that problem. That's why we have algebra, to make some of those things easier and not have to guess and check. Number 2, which of the following numbers is farthest from the number 1 on the number line? And we might be able to see very quickly which one this is, just visually. If we didn't know, we could do some subtraction or counting. It looks like negative 10 is the farthest one away. The answer is A. And then on number 3, we have a graph which is drawn to scale as far as the scale that they give you for the rectangular coordinate system. But we have the graph for the absolute value of 2x plus 4, and they're asking which of the following functions does the graph intersect? Does G intersect the graph that's shown? And one of the things that we might notice, this 2x tells us that we have a slope of 2, or we can count that from these parts of the graph. We have a positive slope of 2 here, or a slope of positive 2 here, slope of negative 2 here. And looking at all of our answers, the ones that have 2x with them, 2x minus 2, that's going to be parallel to this side. And it's going to intersect way down here at negative 2. The other one's going to intersect at 3. Those are not going to intersect with the V graph here that we have, the V line. So we can eliminate some of those right away. X minus 2, that has a slope of 1. If we graph that, it's going to be way down here. It's not going to intersect. If we have x plus 3, that's up here with a slope of 1. That's not steep enough to intersect. But 3x minus 2, if I can show a picture of that, they don't have a picture of that one. But 3x minus 2, we have a slope of 3, which is steeper than this slope. Intersecting down here at negative 2, eventually, because it's steeper, it will eventually intersect with that line. Now we have to know something about the slopes and things like that and how they relate, but that's the only one that's going to make sense once we look at the other ones. They do show in their picture how this first one, I believe that's our x minus 2, how that's with a slope of only 1, it won't intersect with that slope of 2 if it's starting way down here on this y-intercept. In this section, they have 5 sample problems. And it might be a good idea to hide the solution until you have a chance to solve it, just to see what you would do first, and then check their answer. Then we have multiple choice questions where there are possibly more than one answer. Description again, and then tips for answering. Note whether you are asked to indicate a specific number of answer choices or all the choices that apply. And we'll see some of that in the sample questions. How many numbers apply to this, or which ones actually do apply. In some questions that involve conditions that limit the possible values of numerical answer choices, it may be efficient to determine the least and or greatest possible value, and knowing that least or greatest value could narrow down your choices. Avoid lengthy calculations by recognizing continuing numerical patterns. So those are the hints that they give you if we look at the sample questions. Which two of the following numbers have a product that is between -1 and 0? Let me tell you how many answers they're looking for. Which two of these? Correct answer would be -10, and then C is 2 to the -4th, which if you know about your exponents, the negative exponent would actually could be changed to positive as 1 over 2 to the 4th, 1 over 16, which is a decimal fraction between 0 and 1. Also, you might notice that some of them can be eliminated right away, like -20, -10, or I'm sorry, oh, I said that wrong. Which of the following numbers have a product that is between -1 and 0? We have to multiply them together to give us a value between 0 and 1, 0 and -1. So, noticing that if we multiply -20 and -10 together, we're not going to get a value between -1 and 0. So that combination of two would be out. We can do the same thing with any combination of those, -20 and 2 to the -4th, -20 and 1/16, which wouldn't do it. We do that for any pair of them. But you can eliminate some of them possibly early. Which of the following integers are multiples of both 2 and 3 indicate all such integers? When you look through the list and see which ones fit that description, depending on what you know about multiples and how quickly you can pick those up, you might recognize that 3 doesn't divide into 8, but 2 does, so we have to throw out A. B only divides by 3 and not 2, but 12 divides by both of them, 18 by both of them, and 36. So we need evens for one thing, so we can throw out all the odds, and we can see which evens divide by 3. In this part of the test, 4 questions, or this part of the practice area, 4 sample problems. Another type of question is the numeric entry question. Make sure that you answer the question that is asked. Since there are no answer choices to guide you, read the question carefully and make sure you provide the type of answer required. Sometimes there will be labels before or after the answer box to indicate appropriate type of answer. Pay special attention to units such as feet or miles to orders of magnitude such as millions or billions, and to percents as compared with decimals. So pay attention to what information they give you. Make sure you answer with the correct number for that label. If you're asked to round your answer, make sure you round to the required degree of accuracy, tenths or hundredths or whatever they ask for. And examine your answer to see if it's reasonable with respect to the given information. Typical for any type of math problem. Sometimes we solve it, we do something wrong, we get an answer that's way out there, not even close to being correct. We should at least recognize at times that we are way off base. At the bottom again, we have sample questions. Looking at some of the samples. One pen costs 25 cents and one marker costs 35 cents. At those prices, what is the total cost of 18 pens and 100 markers? Basically multiplying our cost times the number of pens and cost times the number of markers and adding. Here we have $39.50. And they didn't, they tell you that you can have some different ways of expressing this that would still be counted correct, like $39.5 or $39.500. They count those correct because they're both equivalent to $39.50, but $39.50 is what they really want. It says, note that the dollar symbol is in front of the answer box. So the symbol dollar does not need to be entered in the box. In fact, only the numbers, a decimal point, and a negative sign can be entered into the answer box. Don't duplicate the symbol they give you. Just type in the numbers as you should. The second problem. Rectangle R has a length of 30 and a width of 10, and the square has a length of 5. The perimeter of S is what fraction of the perimeter of R? Perimeter of S is what fraction of the perimeter of R? So we need the perimeter of S, and if we add 5 fours together for the perimeter we get 20 and for 80. So the two values, 20 and 80, can be put into a fraction. S in the numerator, R in the denominator. Perimeters of those. So we have 20 over 80, which reduces down to 1/4. They want the fraction that gives us that. They say that the correct answer, even though we could reduce 20/80ths down to 1/4, we could give 20/80ths or any equivalent fraction to that. So be aware of that type of thing. In this part of the practice, they have 5 practice problems for you. That was for numeric entry. And then data interpretation sets. Again, a description of the type of test, and then tips for answering. You scan the data presentation briefly to see what it's about, but do not spend time studying all of the information in detail. Focus on the aspects that seem to be more important. Pay attention to the axes and the scaling of the graphs in the right units and so on. Bar graphs and circle graphs, as well as other graphical displays of data, are drawn to scale, so you can read or estimate data visually from such graphs. So they're going to try to draw them to scale for you in this case. The questions are to be answered only on the basis of the data presented. Everyday facts such as the number of days in a year and your knowledge of mathematics. Do not make use of specialized information we recall from other sources about that context of the problem. So don't bring other information in, just use your knowledge of math and what they give you in the problem. For the first example, annual percent change in dollar amount of sales at 5 retail stores from 2006 to 2008. Notice they have percent change from 2006 to 2007, and then percent change from 2007 to 2008 with positives and negatives. Looking at the first question, if the dollar amount of sales at store P was $800,000 for 2006, what was the dollar amount of sales at the store for 2008? So notice it's from 2006 all the way to 2008. If you look at the percentages, it increased by 10% and decreased by 10%. Be careful not to think it's right back at the same value you started at, because that second 10% is going to be a bigger amount than the first 10%, since we have a higher value at that point. It says if we increase 10% from 2006 to 2007, then we're up to $880,000. So, and then if we take off 10% of that, or like they said, 90% of that, we're taking 10% off of it, we're left with 90% of it, then we're left with $792,000. The correct choice is B, $792,000. And we added 10% to get a bigger amount, but then we took off 10% of a bigger amount, which means we're going to have less than the $800,000. At store T, the dollar amount of sales for 2007 was 1% of the dollar amount of sales for 2008. Give your answer to the nearest tenth of a percent. And then they go through the solution for this. They're saying that if you set up an equation, the amount minus 8% of the amount equals 92% of the amount, you can solve that to eventually get 108.7%. In this part of the test, just 3 problems. Now, on what I just talked about, I wanted to just briefly hit those different types of tests. Just look at the STEM problem just quickly. If you have questions on more things, you can always ask if you have. Those are the different types of questions that you'll be asked. But now let's get into some of the other information that this provides you with. For example, using the calculator. And I won't go through the whole use of this, but if you look at the calculator, it's a fairly simplified calculator with a few of the square root keys and stuff like that, but all your operations, parentheses, memory, and so on. And it should tell you how to use the calculator as far as some of the order of operations that you would use, or the order of punching buttons. If you look at the guidelines, this is in this part of the section here. Most of the questions don't require difficult computations, so don't use the calculator just because you have it available. You do things more quickly without a calculator, then do them more quickly. Do it quicker than that. Like they said here, avoid it for simple calculations such as some of these things here. Avoid using it to introduce decimals if you're asked to give an answer as a fraction. You don't get a complicated issue if you're doing some of these things just because you have a calculator. Going down a little further, giving you, more hints on how to use the memory keys and so on, or how to use the square root and stuff like that. Here they have some samples for you. Here's an example of 4 plus 6.73 over 2. And in this calculator, it looks like you can enter it pretty much just in order as how you see it. 4 plus, and then 6.72 divided by 2. And it looks like you're going to get it correct that way. It says you can also do the fraction first and divide that out, and then add 4 to get your 7.635. So it looks like it could be done either way. The second one, notice we have a fraction, and in the numerator of the fraction we have several terms, so we need to use parentheses to end it. Or we can add those together separately and then divide that by the denominator. But here they show parentheses use around that numerator, and then divide by 70. And then they hit equals, and then they hit the plus minus to get the negative, but you can do that mentally, possibly. It says here to be careful not to punch in this manner with 8.4 plus 9.3 divided by 70. Without the parentheses, it would do the division first, and then it would do the addition. It would give you the correct answer. So understand how valuable those parentheses can be in putting things in the correct order. Here they have a computation, a square root of 21 squared plus 54 squared, and it says that in this case we want to, or we can, multiply and add, do everything inside of the square root first, and after hitting equals, then hit the square root key. That way it takes that whole value inside before you take the square root, so it does all the addition together. And a few other examples, 6 examples altogether. So since that's available, we know how to use it, but don't overuse it. Under math review, this is something that you probably should look through depending on how familiar you are with the different areas of math and algebra. You might want to look through just to refresh your memory of what's important. Here's a table of contents. If we go through, look at some of the terminology that we see just right away in the beginning part. Integers, fractions, talking about different ways of working with fractions, exponents and roots, decimals, real numbers, also irrational numbers, ratios, proportions. You can see there's a lot of information here. There are 102 pages in this part on this PDF. So I mean, there's a lot of stuff there. Depending again on your background, you might not have to look at all of it, but you might want to look at some of it. See what you don't remember. And then similar to that is the section on math conventions. Let me back up to the overview. The mathematical symbols and terminology used in this test are conventional at the high school level, and most of these appear in a math review. Whenever non-standard or special notation or terminology is used in a test question, it's explicitly introduced in the question. However, there are some particular assumptions about numbers and geometric figures that are made throughout the test. These assumptions appear in the test at the beginning of the quantitative reasoning section, and they are elaborated below. Some things are just accepted that we're going to use regardless of the test, regardless of context, and that's what they're going to show you in this section. All numbers used in the test questions are real numbers, not going to use imaginary numbers or complex numbers. Numbers are expressed in base 10 unless otherwise noted, which we work in base 10, so it's just normal for us anyway. Convention involving large numbers, 1 billion means what we think is 1 billion, one with 9 zeros after it. When rounding numbers, when numbers happen between the two nearest possibilities, you round to the greater possibility. So 23.5 rounds up to 24. Same thing as what we've done. Looking at the different symbols, different notations as far as multiplication, as far as division, fractions, negative signs, powers of 10, and so on. If you've forgotten some of those, it's all there. Oh, back to, you saw order of operations. We work with order of operations, which we basically have, it says it right here, parentheses, exponents, negation, making the negative up, multiplication, division, and then addition and subtraction, left and right for each one of those. Please excuse my dear Aunt Sally if you're familiar with that. So, same thing that we had. Again, these are the conventions that you should be familiar with just because of taking math classes in the past. So if you've forgotten them, there they are. Other notations, one of them that you might have forgotten about would be the factorial. That means basically you multiply all the values of that, all the integers from that value down to 1 together. So 5 factorial would be 5 times 4 times 3 times 2 times 1. Symbolism in geometry, parallel and perpendicular. Also absolute value. In geometry, giving some definitions for you: angles, lines, closed figures like this one's closed, this is not closed, there's an opening to it. Also convex and not convex. This is concave, it's caving in, so it's not convex. Also our figures normally don't overlap each other, the sides don't overlap. Distance, no, it's the shortest distance between 2 points, or shortest distance from a point to a line. Also reminding you that we don't always draw things to scale. Most everything we draw is in a plane and a flat surface unless we specify otherwise. Angles, angle measures as far as acute and obtuse, greater than 90, less than 90. Looking at this figure, some of the things they talk about in here is how they can label sides and lengths and you know, point E on a segment and so on. A lot of information there. L and M, the way they do designate lines with small letters, points with capital letters, and some of the different notations that we have. Coordinate system, if you've forgotten the quadrants, numbered in this order: 1, 2, 3, 4, starting upper right and going around to the bottom right. Also terminology like x-intercept and y-intercept. X-intercept is a value on the x-axis, y on the y-axis. Also, some of the terminology used in statistics, if you've taken a statistics class, data distributions and probability distributions, a lot of these terms are from that course. If you took that course, you might recognize frequency distributions, relative frequency, which are basically the percentages. Probability, what probability means, mutually exclusive events, you know, a lot of different terms in there that you should be aware of. I think that was the last part of it. Oh, here. Miscellaneous guidelines for interpreting information. You know, so again, I'd suggest you read through this for the conventions. look through as much of the other document, that long document for the mathematical information. Like I said, that's a lot of stuff there, but you might be familiar with so much you don't have to read the whole thing. But there's a lot of good information there. And then make sure you go back to the calculator and review, or at least become familiar with the calculator. Use the calculator in the practice problems, use the calculator in the practice test, and then become familiar with all the different types of questions. We covered, I think, 2 from each of those types of questions, 2 or 3 of those, just briefly, just to give you a glimpse of them. Take a little time to dig into those. Like I said, they give you an explanation of how they would solve the problem, maybe a couple of explanations. Feel free to do what they did, but you might want to try first to do something before you jump to their conclusions, before you go to their result, their solution. That'd probably be valuable. As far as the overall test taking, once again, I think one of the most important things you can do with this PowerPrep software, and I download that, for sure if I were you. It gives you all that information that I just showed you for review and to become familiar with the test, but take those other tests. I think we can jump into that. I'm back to prepare for the test. Went back to home. And practice for the test. And then there's a place to launch the practice test. Continue, and then you can get into the actual practice test. Here it says, take the practice 1 test timed or untimed. You review your answers and resume a previously started test. Those are the capabilities. The test 2 is timed. You can still review your answers and resume a previously started test, but your other time. But there's a way of getting in and taking these tests. Like I said, I think in even your regular class and math classes, it's always a good idea to put yourself in a testing situation before you're actually in the testing situation. You'll find a lot more where you actually stand, rather than always being there with help and doing problems. Just like that. That's what I wanted to show you tonight. And like I said, the PowerPrep can be used for any of the test sections. I don't know what type of information they give you exactly on that, but I'd imagine it's the same format as far as the tips, the description, the tips, sample problems. So my recommendation is to get in there and get as familiar as you can with all those sections as possible. I have time now if you have questions that are general to the test, which I may or may not be able to answer, or if you have any kind of math question that maybe I can answer. And then also, if you have questions that come up over the next few weeks or whenever you're going to take the test, feel free to come see if you have some of those questions. Last year, a few students came in and asked some questions from the booklets or whatever they ran across, and that's okay too. Does anybody have any questions on anything you saw or on something specific to content? That's something I don't remember. I think last year I looked some of that up, and I don't know if there's a penalty for guessing or not, and we can find that out. Looking back, I believe we can find that out. Yeah, I think in PowerPrep also, but going back to the website, I think they tell you about a lot of those fine details. Somewhere in here. Not at all. See, I didn't think this one was, but I don't remember that for sure. So guessing, and that's one of those things when you read the rules, make sure you're familiar so you know is it worth guessing or not. I'd say if there are penalties, guess as much as you can when you have to.